Hi, Dr. Wang here. Today we're going to do this assignment called Flowchart Lab 6 and 7. This is going to help us get ready for this week's lab. The instruction is on Commons page under week 6. So in this lab, we're going to digest the PCR product and analyze the digestion product on the gel. So to start, we have this step-by-step protocol already rendered into a flowchart. So we're going to go through this. First of all, the protocol says that we're going to assemble individual digestion reaction containing this ingredient. So I have those information already mapped here. So we're going to assemble a single reaction containing this ingredient. So our starting material is PCR product from the previous lab, lab 5. We have 25 microliter of it. And we also have 10x buffer and a number of enzymes that's considered 100% pure for the purpose of calculation. So we can see that this is a lab that again requires the assembly of master mix. So I have this calculation already set up. So if you need any reminder, please go to lab 3 flowchart for a more detailed explanation of what is master mix. So I'm going to point out the common ingredient. So the common ingredient in this case is the enzyme, the buffer, and the water. So those three, I'm going to circle them, are the common ingredients that's present in all the reactions for the digested. And the PCR product, since we have 3 individual PCR product, this is considered as unique ingredient. So again, we're going to calculate the volume of each ingredient one at a time. To calculate this question mark, for example, we are going to assign values first, right? So this is the C2, this is the concentration of the buffer in the diluted solution or solution 2. And then the starting material, this is what we consider as concentration 1. And then how much of it to use, this question mark right here, this is the volume of the starting material. And then the volume of the diluted solution or the reaction, this is our V2. All right, so this is a C1V1, C2V2 question, and you can just repeat the step for the remaining ingredients. So this is how to calculate master mix, solving the value for A, B, and C. Just remember that everything here should add up to be 20. Right? So those 4 values add up should be 20. Once you finish the master mix digested, you can do similar steps for master mix undigested. The only difference between those two is the undigested doesn't contain any enzyme. It only contains buffer and PCR product as indicated on the protocol. All right, so this is how to solve the value for D and E. To solve the value for F, and so what we're going to do is take the total volume of the master mix, right? So take a sum and then divide by 4 because the master mix is enough for 4 reactions. So divide that value by 4, you're going to get the value for F, and the value for H is already calculated right here for individual reaction. So this is how do we attempt question from 1 all the way to question number 7. So question number 8, so this lab is a bit unique because depending on which mutant that you get, is mutant 1, 2, 3, or 4, you're actually going to use different enzymes. So, and different enzymes have different reaction conditions. So here in question number 8, you're going to read the manufacturer's manual for the enzyme and figure out that information. So I'm going to do 1 as an example, right? So BSMA1. The manual for this enzyme is located on the Commons page. If you go to the resource, so we're going to look at this enzyme BMR1. All right, so this is going to lead us to the manufacturer's website, and then scroll down, you're going to see that information under reaction condition. So this is the name of the buffer for that enzyme, and this is the incubation temperature. So this is how to solve question 8. Right? So So question number 9 is actually preparation for lab 7. So once we have done the restriction digestion, we're going to mix the digested product, which is a solution, with a loading dye. This is a 6x loading dye. So let me just go back to the comments page. We're now right here, right? So once we have the gel ready, you're going to prepare the sample for loading, and then you're going to add a 6x loading dye to your reaction product. And then this is going to give you final concentration of 1x. So now the sample is ready to load. So I have a little flow chart already here. So this is how to solve this calculation. We start with the reaction mixture, which is right here. Right, so this is 20 microliter. So we have 20 microliter. We're going to mix that with question mark microliter of the 6x loading dye. So in this case, 6x, x is an artificial unit. So is our C1. This is the initial concentration. So this question mark right here, this is our V1, right? So how much of it we're going to use. And once you mix up these two, you're going to end up with a mixture. The volume of the mixture should be this two initial volume combined. Right, so this is the V2. And then the concentration as indicated in the protocol is 1x. 1x is the working concentration. So now we can set up the equation C1, which is 6x multiply question mark microliter should equal 20 plus question mark multiply 1x. So here's the equation. Sorry, I missed the microliter here. All right, so all you have to do is to cancel unit first, and then move the question marks together so that you can solve question mark. All right, so this is what I want to say for this assignment.